Hello everyone, welcome to Tuteetute. In this video we will see the problems on oblique incidence and normal incidence. The first problem is, if a right-handed circularly polarized wave is incident normally. So here very important point is normal incidence. Okay. On a plane perfect conductor, this is also important, perfect conductor. Then the reflected wave will be, if you see the options, we need to talk with respect to polarization. Okay. So the incident wave, what type of polarization it has? Circularly polarization, that is also right-handed. And normal incidence is there. So when you talk about normal incidence, we know that reflection coefficient is real. So there is no change in the phase. When there is no change in the phase, circularly polarization means phase difference is 90, that phase difference will be maintained. Okay, but gamma value is not equal to 1 actually, but we are incidenting on perfect conductor, so everything will be reflected back. That means gamma is 1, magnitude of gamma is 1, and the angle of gamma is equal to 0. That means no changes. Okay, no changes will be there. But here gamma is equal to 0 means this is valid, this is not valid for this particular perfect conductor. This can be taken for the normal incidence. That too, if you take second medium is the perfect conductor, okay, then this will become 180 degrees. That means phase will be different. There is no changes in the magnitude levels. Everything will be reflected, but the polarization will be different. How? We have seen right-handed circularly polarization, so the reflected wave will be left-hand circularly polarization. Circularly polarized is common, but we have here perfect conductor, so that it will become left-handed circularly polarization. So option B is the correct option. Next question. A plane wave of wavelength lambda is traveling in a direction making an angle 30 degrees with the positive x-axis. So phi x is equal to 30 degrees and 90 degrees with the positive y-axis. Phi y is equal to 90 degrees. Okay. And they did not give about angle related to z-axis. So this is what we don't know. The electric field of the plane wave can be represented as, so electric field equation we need to find. Okay, so even we don't have this phi z, we can get from the relation cos square phi z, phi x plus cos square phi y plus cos square phi z. According to that relation we can able to get actually. So if you observe that one, cos square 30, cos square 30. Cos 30 is root 3 by 2. Square means how much you will get? 3 by 4. Plus cos 90 is 0. Plus cos square phi z is equal to 1. So by sending this 3 by 4 this side, you will get 1 minus 3 by 4, that is 1 by 4. That means cos phi z is equal to 1 by 2. That means phi z is equal to 60 degrees. So this one we got, that is 60 degrees we got. So we have now all the angles. When the wave is making 90 degrees with the y-axis, what is the meaning of that one? It is traveling in the y direction. Okay. Sorry, this electric field is oriented in the y direction. So if you see the options, all the electric fields are having y oriented only. So one thing is over. Now in which direction it is traveling? Since these are making some angles 30 and 60, so the wave is traveling related to x direction and z direction. That is what we need to understand. Okay. And generally the wave representation is given by, with main thing is phase, that phase I am taking e power minus j beta. Here we have to take the normal. Okay, what is the projection? What is the projection of that particular wave on the constant phase plane we have to take. In our oblique incidence concept, clearly I have told this particular representation. And this OA bar is given by n cap dot r bar. And n cap can be given by using the direction cosines. And here we can get x cos phi x plus y cos phi y plus z cos phi z. Okay, n cap means cos phi x x cap plus cos phi y cap plus cos phi z z cap. R bar means x x cap plus y cap plus z z cap. By taking the dot product, we will get this one. And this term is 0 because phi cos 90 is 0 because phi y is equal to 90 degrees they have given. Now you can able to calculate. And they have given wavelength is also lambda, so that directly we can able to utilize this particular expression only. So e power minus j, 2 pi by lambda will be there. So 2 pi by lambda x and cos phi x, that means cos 30 root 3 by 2 plus this is z and beta is there 2 pi by lambda z cos 60, that is 1 by 2. So e power minus j and here 2 will be cancelled, so root 3 pi x by lambda plus 2 will be cancelled means pi z by lambda. This is what we can get. Okay, so and here we can write e power j, here time variation is also given, omega t minus beta oa bar, like this we can represent na. So e power j omega t omega t omega t, and because here minus is there, you can see here minus root 3 pi by lambda minus pi z by lambda. So option A is the correct option. Okay, then a plane wave is characterized by E bar is equal to 0.5 x cap plus y cap into e power j pi by 2 e power j omega t minus kz. This wave is, what type of polarization is there? That is what we need to write. So 0.5 x cap plus y cap e power j pi by 2, here I am writing once again, and here e power j omega t minus j kz, like this one particular equation has been given. This is the electric field, and polarization can be told with respect to electric field only, na? That is what we need to see. By seeing this equation, we can understand that it is having two components, okay, and phase difference is 90, and those two components peak values are 0.5 and 1 only, okay, and these two are not equal. Ex naught is not equal to Ey naught, so surely it is not Cp, okay, and the phase difference is 90, so phase difference is 90. To have LP, we should have phase difference is 0 or 180, but here it is 90, so LP is also no possibility. So CPLP is not there means it should be EP only, okay, that is what you need to understand. So elliptically polarized. A monochromatic wave, plane wave of wavelength lambda is equal to 600 micrometer is propagating in the direction as shown in the figure below. EI, ER, ET denote the incident, reflected and transmitted electric field vectors associated with the wave. This is the data related to the question, and this is the diagram they have given. So oblique incidence, this is the interface here, and this is the incident wave, this is the reflected wave, this is the transmitted wave, and this is the normal to the interface. Now this is the interface in this particular case. In the problem they have given this is the interface, so this will be the normal to the interface. So we have to make theta I, theta R and theta T with respect to normal to the interface. So they have given this is the normal, this is the reflected wave, so they have given theta R. Theta R is equal to 45. That means according to Snell's law of reflection, theta I is also 45. So this will become 45 degrees. And what about theta T? This is a transmitted wave. It is making the angle with normal, that is 19.2. So theta T is equal to 19.2 degrees. So all the angles are available with us. Now what we need to do? If you see the question, the angle of incidence theta I and the expression for theta IR, sorry EIR. Angle of incidence is equal to angle of reflection, that is 45 degrees. So option B or option C. Okay, both are having 45 degrees only. So answer may be B or C. Now what we need to have? EI, that means incident electric field equation we need. Okay. So if you see the options B and C, so peak amplitude level is same. The orientation of electric field is also same. AX cap minus AZ cap they have given in both the things. But the concentration must be on this particular phase. Okay. So how to take phase now? Actually it is parallel polarization. It is not perpendicular polarization. This electric field is available in the plane of incidence, so that it is a parallel polarization. Now we need to get the phase related to this one. Okay, the phase related to this particular thing we need. So how to solve this particular problem means, phase means already we know it is beta OA cap we have to take, it is a phase. Okay, so beta into OA cap is nothing but n cap into r bar. Next, so beta into n cap is cos phi x x cap plus cos phi y y cap plus cos phi z z cap. Like that we have to take. That means we need angles made by the incident wave. We need angles made by the incident wave with respect to x, y, z axis respectively. That is what we need to see now. So this is the incident wave. How much angle made by this incident wave with respect to x axis? That is what we need to observe. So this is 45 degrees is making with respect to normal. If you extend this one like this, that is also making 45 degrees with the positive x axis. Okay, that means phi x is equal to 45 degrees. And what is the angle made by this particular incident wave with respect to y axis? So here y axis is actually available in the plane of incidence. So that is 90. Phi y is equal to 90. Next phi z. So this is the incident wave. With respect to z, how much amount of angle is made? That is what we need to observe. So this is a z axis already. So that is also 45. So phi z is equal to 45. So what is n cap now? Cos phi x x cap. That means 1 by root 2 x cap. It is cos 90 is 0. So y component will not be there. Plus 1 by root 2 z cap. This is n cap. Okay. So n cap dot r cap is nothing but just we have to do the dot product with respect to r bar, that is xx cap plus yy cap plus zz cap. So x by root 2 plus y by root 2. This is what we will get. What is beta? Because in the phase we have beta. We have calculated this n cap dot r cap. But what is this beta? Beta is equal to 2 pi by lambda. 2 pi by lambda means what? They have given 600 micro. So 600 micro, that is equal to pi by 3 into 10 power 4. This is beta. And this beta should be multiplied with this n cap dot r cap. So which option is suitable for that? Option C is suitable, not B. B is having only one component only. So option C is the correct option. So you need to know how to write n cap. You need to know how to write this beta into n cap dot r cap. This is major thing is n cap. Okay, that is what you need to understand. And the next question is also based on the same data only. Here angle of incidence is theta I and the expression for theta, Next question is also based upon the same data only. Here we need to get the expression for ER, that means a reflected electric field. This is what we need. Okay, reflected electric field. So if you see the options, the peak amplitude is different in all the options. That means if you can able to have this peak amplitude, the problem is over. So how to get that one? And by observing the diagram, already I told that it is a parallel polarization. So get the reflection coefficient value. So if you have reflection coefficient, that is for the parallel wave, parallel polarization, what is the equation? Eta 2 cos theta t minus eta 1 cos theta I by eta 2 cos theta t plus eta 1 cos theta I. So using this particular thing, we can able to get gamma value, and it is actually equal to ER by EI. So some value you will get here. From that you can get ER is equal to gamma parallel into EI. So if you calculate, you will get 0.23, and that too, this particular thing will be negative number you will get. Okay, so that option A will be the correct option. Like that you can able to solve. Okay, transparent dielectric coating is applied to the glass, which is having the relative permittivity is 4 and relative permeability is 1, to eliminate the reflection of the red light. Having the free space wavelength is equal to 0.75 micrometer. The minimum thickness of the dielectric coating in micrometer that can be used is, Okay, the thickness of the coating we need to find. So the problem should be understood like this. This is the glass material. Here some coating has been given. This is the coating. And here free space or the air will be there. This is glass. And this is the coating they have given. So what they are telling? We need to calculate the minimum thickness of this particular coating such that no reflections will be available. So by seeing this particular structure, what you are getting the idea? Here it is related to 3 medium problem. Okay, 1, 2, 3, 3 medium. So for not having the reflections into the glass material, what is the thickness? Lambda by 4. That's it. Okay, so we need to calculate the lambda by 4 value. So first we have to calculate lambda. Then if you divide with 4, problem is over. But lambda is equal to lambda naught by, it is having certain relative permittivity, that is epsilon r. So it is equal to lambda naught by root 4. Sorry, this glass material is having 4. So what is the epsilon r value for this particular coating material, that we don't know. So that one I am representing with the epsilon r2. That is what we need now. Okay, so we need to calculate that one. But another condition we have now, that is eta 2 square is equal to eta 1 into eta 3. Okay, using this thing we can get eta 2 is nothing but root of mu by epsilon. So root of, and the root will be cancelled using the square, so that we can write mu r2 by epsilon r2 is equal to, and here we can write root of mu r1 by epsilon r1, and here it is mu r3 by epsilon r3. In this way we can write. Okay, and in general all the permittivities, all these things will be same, so that we can write here epsilon r2 square is equal to epsilon r1 into epsilon r3. It is equal to 4 into 1, that means epsilon r2 is equal to 2. Okay, so what we can do here, by having this particular epsilon r2, we can get the value of lambda. Okay, then this lambda by 4 you have to calculate, and it will be around 0.113 micrometer. That will be the answer. Okay.